Okay, so in this lesson, we're going to continue our study on using the AC method to factoring trinomials. And remember, in the previous lesson, and it's important that you go back and look at this previous lesson. Now, when we did this previous lesson using the AC method, all of our examples, the GCF was 1. So these three terms didn't have anything other than common, other than all having a factor of 1. Okay, so in this case, though, in part 2, if you want to consider this part 2, the GCF will be other than 1. So you'll have a greatest common factor to deal with. Now, one of the things I want to remind you is that it's important that you think of these two right here, these two words, AC method and product sum method, at the same time, okay? Because AC, remember, that's a product, so hence the idea of product. And so if I look at number 1, and so let's say number 1 is 12y squared plus 24y minus 15, okay? And we know that those three terms, the GCF is 3. And remember, when you're factoring polynomials, you always want to factor out the GCF first. But we saw there are situations where you may have forgotten to do that, and that's fine. At the end is where you would take care of that. So we looked at examples of that in previous lessons. But when using the AC method, it becomes extremely important that you take care of that first. Because look, if you do not factor out the GCF, notice what happens. You remember our product sum? So when we looked at product sum, the product is the product of A and C. And remember, A is a coefficient of y squared in this case, so that's 12. And C is your constant, and that's negative 15. So if I multiply that out, notice what happens. 12 times negative 15 is negative 180. And I want the sum. So basically what you have to do is you got to figure out, well, what two numbers multiplied together is negative 180 and whose sum, remember the sum is B, and the sum is 24. Well, that's a task that may not be easy to deal with. But if I had factored out the 3, like I should have at the beginning, if I had done that, notice what happens. 3 times 4y squared is 12y squared. 3 times a positive 8y is 24y. And then 3 times a negative 5 is negative 15. And then if I look at this trinomial now, 4y squared plus 8y minus 15, notice how much easier the product sum becomes using this instead of this. So notice that A is the coefficient of y squared. Now remember, let me just make a remark. So remember, when doing the AC method, you need to write this in standard form, so in descending order. So this should be in descending order to begin with. So I get A is 4, C is negative 5, and B is 8. And so the product, watch what happens. The product, remember the product is AC, which is 4 times negative 5, right? And so if I look at that, that's negative 20. You see the difference? I would rather find two numbers whose product is negative 20 and whose sum, remember the sum is B, which is 8, than finding two numbers whose product is negative 80 and whose sum is 24. So see how important it becomes to factor out the GCF when using the AC method? Okay, so always remember, and that's true for any time you're factoring, always deal with the GCF first. Factor out the GCF first. It makes things so much easier to deal with, regardless of whether you're using trial and error or the AC method. So let's continue on with this now. Okay, so now remember in the previous lesson, so that's why I want you to go back and review the previous lesson, because in the previous lesson, we kind of did this in two ways. So we looked at the idea that x, all right, and when we did that x, remember we put the word product here, and in this little part here, we put the product, which is what I want, of negative 20. And down here we put the word sum, which I want to be 8. And these little spots here are the two numbers whose product is negative 20 and whose sum is 8. Then we also use, and this helped in situations where these two weren't easy to deal with, but in this case it is though, but there are situations where it won't be easy to deal with, like something like this. So we also looked at that table format. So we want to find two numbers whose product is negative 20, okay, and whose sum is 8. So I want to find two numbers whose product is negative 20 and whose sum is 8. Now, remember our discussions in previous lessons. So these two numbers, remember when I multiply them, I want them to be negative, right? So that means that these two numbers have to have different signs. And then so one has to be negative, one has to be positive. But we also discussed this. Be strategic with this. I want the sum to be positive, correct? I want the sum to be positive. Well, so for example, if I used 5 and 4, now I know that 5 times 4 is 20, but I want a negative 20, but I know that 5 and 4 is 20. Which of those would have to be positive for me to end up with a positive number? So if one's negative, one's positive, then the larger of these two numbers would have to be positive in order for me to get a positive number. So which means that if I want this product to be negative, then I will make this be negative, because when I add them up, I will get a positive number, which is what I wanted, because 5 plus negative 4 is 1. Now, if you forget about that, if you don't have to do this, you don't have to think like that. You can just say, well, I'm going to make one negative, one positive. Okay, fine. But you still have to add them up, right? And so negative 5 plus 4 is negative 1, which is not what you wanted. So you continue on with this process. You continue dealing with, well, now I've got to find something else then, because what I used doesn't work. So then you may say, well, I'm going to use, and remember, you got to use factors of 20, okay, factors of 20. And so let me remind you about something else that we did before we continue on, because this is sometimes useful. It's not going to be that useful here because negative 20 and 8 is not that difficult to deal with. But remember, we use the factor tree. So remember the factor tree. So when these situations become a little bit more difficult to deal with, use a factor tree. And we did that. And let me just kind of remind you, we did that in a previous lesson. So let me see if I can find it real quick. So remember this factor tree? All right, see how these numbers, we used it with those very large numbers, okay? So for the factor tree is where you're actually writing the prime factorization of, in this case, 20. Now I know it's negative 20, but you always find the prime factorization of positive numbers. And so basically you use the factor tree. So you want to end up with, remember, prime factorization means that every composite number, remember, numbers are either prime, whole numbers are either prime or composite. And so this whole number is not prime, it's actually composite. So you're going to rewrite this, as a product of prime numbers, prime factorization. So find a prime number that goes into 20. Well, since 20 is even, 2 is a prime number and it goes into 20. So 2 times 10 is 20. 2 is prime, so I'm going to circle it because I can't go any further with it. But 10 is not prime, but I can write 10 as 2 times 5. And now those are prime, and so I'm done. So 20 I can write as 2 times 5. Okay? And so basically what we did was remember, when finding two numbers whose product is 20, you just pick any two factors here and make that one of your factors. So for example, 2 times 2 is 4, and I already used it, right? And then you may say, well, what about 2 times 5? Okay, well, let's use it. So that's 10. 2 times 5 is 10. Now 10 times what's 20? Well, 10 times 2. Now remember, I got to make one negative. So you may say, well, I'm going to make this one negative. Okay, that's fine. So if I make 10 negative and 2 positive, that product is negative 20. But when I add them up, what do I get? I get negative 8. What did you want? A positive 8. Well, now let's think. And that goes back to discussions we've had before. Well, now those are opposites. Negative 8, that's the opposite of what I want. Well, all that means is that since those are opposites, all that means is I just change the signs. So instead of negative 10 and 2, I should have picked 10 and negative 2 because that sum is 8. So once you find the one that works, then that goes here, 10, negative 2. Okay? Now, once you find it, remember the AC method, once you find the two numbers that go here, then you're going to rewrite, let me go ahead and put that here, 4y squared plus 8y minus 5. So then you're going to rewrite the middle term using two terms, because remember the AC method involved grouping. So the AC method involves grouping. So you got to go from 3 terms to 4 terms. And so 8y is where you're going to use this. So I get 4y squared. And remember in previous lesson, it did not matter whether you put 10 first or negative 2 first. It does not matter. All right, so I'm going to go ahead and put 10 first. So plus 10y minus 2y. So remember, the AC method, you're going to split that middle term into 2 terms. All right, now make sure you don't forget the variable. So that's 10y and a negative 2y is 8y. So always double check. And then minus 5. So you see I went from 3 terms to 4 terms. Now the rest is easy because you've had experience with the rest. So the rest is just using grouping. So I'm going to group the first 2, the last 2. In the first group, I can factor out a 2y. And I get 2y times 2y is 4y squared. And then 2y times 5, 2y times 5 is 10y. In the second group, what's the GCF of the second group? Now remember, you got to factor out that middle sign. So a negative what? A negative 1. And so you get negative 1 times 2y is negative 2y. Now remember, when you factor out a negative GCF, always be careful. And a negative 1 times a positive 5 is a negative 5. And now notice if I'm doing it all this correct in the original problem right here, well, not the original problem, but this trinomial is factorable, these two should have a common factor, and they do. So the GCF of these two groups is 2y plus 5. So I'm going to go ahead and factor out 2y plus 5. And when you factor out the 2y plus 5, you get 2y minus 1. So you get 2y minus 1 that goes here. So 2y minus 1. And then, again, so you're done. But again, always double check. It's very easy to check your answers when you're dealing with factoring. So 2y times 2y is 4y squared. And then your last 5 times a negative 1 is negative 5. And then your outer and your inner, notice what happens. The outer is negative 2y, which is what this is. Your inner is 10y, which is what this is. Okay, and when you add them up, you do get 8y. Okay, now, be careful. So remember, your original problem was not this. Your original problem is this. So now the answer to the original problem is what? So many students forget about the GCF. So they'll take this right here. They'll take this right here and put that as the answer. But remember, that is the prime factorization for this. You got to remember you're factoring this. So don't forget about the GCF. So you're going to say 3 times 2y plus 5 times 2y minus 1. Okay? So that's the answer to the first one. Now remember, multiplication is commutative. So you have 3 factors here. 3, 2y plus 5, and 2y minus 1. So there are 3 factors. The order in which you multiply them does not matter, but we prefer to put the monomial first. And then these 2 binomials you can put in any order. So someone else could have said 3 times 2y minus 1 times 2y plus 5. Okay? All right, so that was number 1. Let's look at number 2. Okay, so number 2, we have 24x squared minus 68x plus 48. All right, so that's number 2. So 24x squared minus 68x plus 48. Okay, so again, look for the GCF. So if I look at number 2, 24x squared, negative 68x, and positive 48, the GCF, the greatest common factor, is 4. So the GCF here is 4. Okay, so again, when using AC method, it's very important you deal with the GCF first, because look, if you did AC right away, 24 times 48, Look at this, 24 times 48. You get 1,152. Do you want to find two numbers whose product is 1,152 and whose sum is negative 68? No, you don't. So do the GCF first. Okay, so I'm going to factor out the GCFs. I get 4 times, so 4 times 6x squared is 24x, and then 4 times, that should be negative 17, but if you're not sure, always check. So 68 divided by 4 gives us 17. So minus 17x, and then plus, and that should be 12. Okay? Now, we're going to use the AC method on this now. So use the AC method on this. So let's go off to the side and rewrite it. So I have 6x squared minus 17x plus 12. So we use the AC method on this. Now, let me remind you, in Canvas, you should have a file, and we used this in the previous lesson. So these are the steps that we use to go to when factoring a trinomial using the AC method. So if you need to go back and look at this as we go through the process, and go back and do that. Okay, so A in this case, remember the AC method, product sum. So I want to find two numbers whose product is AC. Now remember, A, and it's very important that you're careful with writing this. You got to make sure these are all correct. So A is 6, okay? C is your constant, which is a positive 12, and then B is the coefficient of your x term, which is negative 17. Okay, so be careful. Don't say 17. It's negative 17. And so the product then is 6 times 12. So 6 times 12, which is, and then just use your calculator, 6 times 12, which is 72. So you see, it's so much easier to find two numbers whose product is 72 rather than two numbers whose product is this. Okay, so that's why it's important you do the GCF first. Okay, all right, so the product is 72, and I want the sum to be negative 17. All right, so let's go ahead and use that x in our table. So I want to find two numbers whose product is 72 and whose sum is negative 17. And those two numbers that work, I'm going to put that here. And I'm going to go ahead and use a table to help me as well. So I have a product. I want the product to be 72, and I want the sum to be negative 17. Okay? And so I want to find two numbers whose product is positive 72. Now, again, think. The two numbers here, when multiplied, have to be positive, right? So in order for that to happen, that means that either they're both positive or they're both negative. Y'all agree? Okay. So either they're both positive or they're both negative. But look at what you want. You want the sum to be negative. So when you add two positives or two negatives, which one gives you negative? Well, when you add two negative numbers. All right. So remember, these two numbers we're going to put here will be negative, because I want the sum to be negative and the product to be positive. All right, so just think like that. It does help at times to make things a little bit easier for you. So what may help, rather than just guessing at factors right off the bat, although you could, you may want to do the t-table. The factor tree. So let's find the prime factorization for 72, just like we did this one. So the prime factorization for 72. All right, so remember, you want to write 72 as a product of prime numbers, and that will help us with finding some of these factors here. So remember, you want to start out with a prime number. So what prime number will go into 72? All right, obviously 2, right? So 2 times what's 72? Well, 2 times 36. Y'all agree? All right. Now, 36 is not prime, so that means I can break this down further. So give me two numbers whose product is 36, where one of them is prime. Okay, for example, 3. Y'all agree? 3. Someone else could have said 2, right? Okay, I'm going to say 3. 3 times, what's that, 12 is 36. So 3 is prime, so I'm going to circle it. I'm going to go with 12 now. Give me two numbers whose product is 12, where one of them is prime. 3 again, right? Someone else could have said 2. But 3 times what's 12? 4? 4, 3 is prime. And then 4 is 2 times 2. So what that means then, and then the 2's are prime. So I'm done. So that means I can write 72 as the product of all these prime numbers. So 2 times 2 times 2 times 3 times 3. All right? And so what you're going to do with this now, what you're going to do, see there are 1, 2, 3, 4, 5. There are 5 factors. What you're going to do is you're going to take 2 at a time, multiply them, and put that here. So for example, let's say 2 times 2. All right? 2 times 2 is 4. All right? So that means that 4 will go into 72. So let's see what it is. So 72 divided by 4 is 18. Okay. Now remember, you want the product to be 72, a positive 72, and this is, but you want the sum to be negative 17. So that means that both of those have to be negative. But when I add them up, what do you get though? You get a negative 4 and a negative 18 is a negative 22. Is that what you wanted? No. So then you go back to your factor tree. You go back to your prime factorization. So instead of saying 2 times 2, well, let's say 2 times 3 then. 2 times 3 is 6. So that means that 6 will go into 72. So let's find out what that other factor is then. So 72 divided by 6 gives me 12, right? Okay, so 72 divided by 6 gives me 12. And again, they both have to be negative. But when I add them up, what do you get? You get negative 6 and negative 12 is negative 18. Is that what you wanted? Nope. All right, well, let's go back to our factor tree. So I tried 2 times 2. I tried 2 times 3. Let's try 3 times 3. So 3 times 3. So 3 times 3 is 9, right? And so 72 divided by 9 gives me 8. Again, they both have to be negative because I want my sum to be negative. And then look what happens. What is negative 9 and negative 8? Negative 17. So I found it, right? So I'm going to put negative 9 and negative 8 here. And so those are the two numbers I'm going to use to rewrite this middle term. So let's go off to the side now. Let's go off to the side and then rewrite this. So 6x squared minus 17x plus 12. Because remember, using the AC method on this. So I'm going to rewrite the middle term using those two numbers. And again, it does not matter whether you put negative 9 here, negative 9x here, or if you put negative 8x here. It does not matter. Okay, so I get 6x squared minus 9x minus 8x plus 12. And so now I'm going to use use grouping on this now. So I'm grouping the first two and the last two. So if I group the first two, I can factor out a 3x, and I get 3x times 2x is 6x squared, and then 3x times a negative 3 is a negative 9x. In the second group, I can factor out a negative GCF. In this case, it's 4. So negative 4 times 2x is negative 8x, and then a negative times a negative is a positive, and so that needs to be, a negative times a negative is a positive, yes. So that needs to be a negative 3. And then remember, if I'm doing all this correct, and this is factorable, then these two should be the same factor. So I can factor out now the 2x minus 3. So I get 2x minus 3. Now whenever I factor out the 2x minus 3 from these two groups, I'm left with a 3x and a negative 4. So 3x minus 4. All right, so now remember, that's the prime factorization for this. Now before you go on to the original problem, always verify that you can't do anything further with this, because you could have messed up somewhere along the process. So be careful. So 2x minus 3, the GCF of those is 1. 3x minus 4, the GCF is 1. And let's check. 2x times 3x is 6x squared. A negative 3 times a negative 4 is a positive 12. And the outer should be one of these. So the outer 2x times negative 4 is negative 8x, which is what this is. And then the inner negative 9x, which is what this is. And when I add them up, I get negative 17x, which is what you wanted. Okay, so I'm going to put that here now. So don't forget though, the GCF is 4, so you have to write it down because that's one of your factors. So 4 times 2x minus 3 times 3x minus 4. And again, always write the monomial first. Now, someone else could have written it as 4 times 3x minus 4 times 2x minus 3. Does not matter, okay? All right, so that's number 2. Okay, let's look at number 3. Let's suppose in number 3 I had this. So this is number 3. All right, so number 3. All right, we have 9x squared minus 21xy minus 18y squared. So 9x squared minus 21xy minus 18y squared. Okay, so notice in this case we have two variables, so always look for that as well. So you got to be careful. So in your answer, you're going to have factors involving two variables, x and y. Okay, now notice though that x squared is listed first. So just make sure, since x squared is listed first, that your second term is x, and the last term does not have an x in it. Okay. All right. Now, what is the GCF here? The GCF should be what? 3. Is that correct? All right. So the GCF is 3. So let's go ahead and factor out at 3. So I get 3 times 3x squared minus 7xy. Don't forget that, 7xy. And then minus 6y squared. Okay. So I'm going to use the AC method on this trinomial. So let's go off to the side and rewrite it. So 3x squared minus 7xy minus 6y squared. All right, now remember, be a little bit careful when you have two variables. It kind of throws students off. So when you talk about A, B, and C, A is, remember we wrote this in terms of writing in descending order in terms of x. So x squared, x to the first, and no x. So A would be the coefficient of x squared, which is 3. C would be the coefficient of y squared, which is negative 6. Now be careful, make sure you say negative 6 and not 6. And B is a coefficient of the xy term, which is negative 7. Okay? All right, so I want to find two numbers whose product is AC. So in this case, it's 3 times a negative 6, which is negative 18, right? And whose sum is B, which is negative 7. So let's go ahead and use that x in our table to help us. So I want to find two numbers whose product is negative 18 and whose sum is negative 7. Now some students can find it real quickly and they don't need to do that table. That's fine. Some of you may need to do the table. So let's go ahead and do the table. Let's go through the thought processes. So I want the product to be negative 18, right? And I want the sum to be negative 7. So I want to find two numbers whose product is negative 18 and whose sum is negative 7. So two numbers whose product is negative 18 and whose sum is negative 7. So remember, you want the product to be negative, so that means that one's positive, one's negative, correct? And you want, when you add them up, you want it to be negative. All right, so let's look at the absolute value of this first, 18. Now, 18 is not a difficult number to deal with. So you really don't need, I think, to use a prime factorization on this. So you can just guess at this because it doesn't have that many factors to deal with. So if you look at the absolute value 18, so I know that 2 is a factor of 18. So 2 times 9 is 18, right? Some of you may say, well, what about 6 times 3? Well, true, 6 times 3 is 18. And 18 times 1 is 18, right? Okay, but remember, you want it to be negative, so that means that you better make one positive and one's negative. Okay, so for example, let's look at the 6 and 3. So if I make 6 negative, when I add them up, negative 6 times 3 is negative 18. That product is correct. But when I add them up, what do you get? You get negative 3. Is that what you wanted? No. So if you look at this one, if I make 2 negative and 9 positive, what would you get? Well, the product is negative 18. That's true, but the sum is 7. All right, now look. I have 7. What do you want? Negative 7. So that means that those are opposites. So what you have is the opposite of what you want. So all that means is that you just change the signs. So then what's going to work will be 2 and a negative 9. And so 2 times negative 9 is negative 18. And the sum is negative 7 is what you wanted right here. So I'm going to put 2 and negative 9 here. Or you could put negative 9 and 2. Does not matter. Okay. Now, once you find the one that works, then you go back and you deal with this now. So I'm going to rewrite this over. So I get 3x squared minus 7xy minus 6y squared. And you're going to rewrite that middle term. Because remember, when using AC method is going to involve grouping. So you got to have 4 terms and not 3. So I'm going to rewrite this. I get 3x squared plus 2x minus 9. Oh, sorry. It's not 2x. It's 2xy, right? So be careful. Xy. Okay. Plus 2xy minus 9xy and then minus 6y squared. All right. So always double check that this right here is what you have here. And then when you add them up, you get this back. So notice positive 2xy and a negative 9xy is a negative 7xy. Now I'm going to use grouping on this. So in the first group, I can factor out, it looks like I can factor out an x. So I get x times 3x plus 2y. In the second group, I need to factor out a negative GCF. So it'll be a negative, and that's going to be what? 3y? So 3y. So a negative 3y times a positive 3x. So again, always be careful when you factor out a negative GCF. A negative times a positive is a negative. Now check, is 3y times 3x 9xy? Yes. A negative times a positive is a negative. Okay, so 3y times what's 6y squared? 2y, right? Now, if this is factorable, if you did all this correct and this is factorable, then these two should be the same. These two groups should have a common factor, this binomial. So let's go ahead and factor it out. So I get 3x plus 2y times, and then I'm left with x minus 3y. So x minus 3y. All right, now that, again, before you go on, you may want to double check to make sure you get this back. So 3x times x is 3x squared. A positive 2y times a negative 3y is a negative 6y squared. And your outer and your inner should be these two terms here. So notice the outer, 3x times negative 3y is negative 9xy, which is what this is. And then your inner, 2y times x is 2y, or 2xy, which is what this is. Okay? And when you add them up, you do get negative 7xy. So that's going to go here. Don't forget your GCF is 3. All right, so you get 3 times 3x plus 2y times x minus 3y. And again, always put the monomial factor first. So you have, this trinomial can be factored as 3 factors. 3, your other factor is 3x plus 2y, and your other factor is x minus 3y. Or you could have written it as 3 times x minus 3y times 3x plus 2y. Does not matter. All right, so that was number 3. Number 4, let's suppose we had this in number 4. We have number 4, negative 6p squared minus p plus 15. So negative 6p squared minus p plus 15. Okay, so remember in previous lessons, notice that this is in descending order. That is true. But the leading coefficient is negative. So remember, when you're dealing with the leading coefficient as negative, you should factor out the negative GCF. So in this case, the GCF here, if I'm going to factor out a negative, will be negative 1. So I'm going to write that as my GCF. So GCF is negative 1. So I'm going to go ahead and factor it out. So I'm going to say negative 1 times 6p squared plus p minus 15. And so now I'm going to use the AC method on this. So it becomes a lot easier to deal with when the leading coefficient is positive. Okay? All right, so A is 6, C is negative 15, and then B is a coefficient of P, which is 1. All right, so I want to find two numbers whose product is 6 times, remember it's AC, so 6 times negative 15, and so 6 times negative 15 is negative 90, and whose sum is 1. All right, so you may want to use a factor tree on this. We'll go ahead and use one. So let me go ahead and remind you what we're going to do. So we're going to find two numbers whose product is negative 90 and whose sum is 1. So two numbers whose product is negative 90 and whose sum is 1. All right, so we're going to use a table to help us. So again, product is negative 90, sum is positive 1. Okay, so let's go ahead and actually write the factor tree for that one. So this is, remember, I know it's negative 90, but when we do the factor tree, make it positive 90. So we're looking at the prime factorization of 90. Prime factorization for 90. So remember, prime factorization is where you write a composite number as a product of prime numbers. Okay, so we're going to do the factor tree. So give me a prime number that goes into 90, 2. So 2 times what? 45? Okay. Now let's look at 45. 45 is composite. Give me a prime number that goes into 45. Well, 5. 5 times what's 45? 9. So 5 is prime, so I'm going to circle it. 9 is 3 times 3, and you're done. Those are prime, so you cannot go any further. So 90 will be 2 times 3 times 3 times 5. Okay? So 90 is a product of these 4 prime numbers. 2, and you have 3 listed twice, and you have 5. Okay. I should have said the product of these 3 prime numbers, where 3 occurs twice as a factor. Okay, so what we're going to do is just multiply, find the product of 2 of these factors. So if you want to start with 2 times 3, you can. 2 times 3 is 6. All right, and then you got to figure out 6 times what's 90. All right, well, let's see. 90 divided by 6 is 15. Okay, so 6 times 15 is 90. Now, this is not going to be the one that works because you want the sum to be 1. Now, remember, the product is negative, so that means one of them has to be negative. And be strategic. You notice you want the sum to be positive 1, right? So that means that the larger of these will be positive and the smaller one will be negative. So I'm going to make the negative 6 negative. I'm sorry, 6 negative. So when I add them up, though, that gives me a positive 9. That's not what you wanted. All right, so then let's go back to our factor tree, and let's try something else then. So let's try, instead of these 2, let's try these 2. 3 times 3, 9. Let's see what happens. Okay, well, 9 times 10 is 90, right? And then you want the product to be negative, so one of these has to be negative. Now, knowing that you want the sum to be positive, which one do you think is going to be negative? The 9, yes. So if you made the mistake, I just want to show you, if you made the mistake and you said, and it's really not a mistake because you're just guessing at factors that are working, you checking to see if the sum applies. But if you made, let's say, 10 negative and you add these up, what do you get? Negative 1. So what you have is the opposite of what you want. So all that means is that you just change the signs. So make this 9 negative instead, and now you get 1. So you found your answer that works. So I'm going to put negative 9 here, 10 here, or you could put 10 here, negative 9 here. It does not matter. So now what's going to happen is I'm going to rewrite this. So 6p squared plus p minus 15. So you're going to rewrite that middle term using these 2 numbers now. So I get 6p squared minus 9p plus 10p. And always double check. Negative 9p plus 10p is positive p minus 15. And now let's use grouping. So in the first group, I can factor out a 3p, and you end up with 2p, right? Minus, what's that, 3? Okay, so 3p times 2p minus 3. In the second group, I can factor out a positive, in this case 5, and you get 2p minus 3. All right, so always double check. 5 times 2p is 10p. 5 times a negative 3 is a negative 15. And again, if this is factorable and you did all this correct, then these two groups should have a common factor, and they do. So I'm going to factor out the 2p minus 3. And when I do that, when I factor out the 2p minus 3 from this group, I'm left with 3p. And when I factor out 2p minus 3 from this group, I'm left with plus 5. All right, and so this is your prime factorization for this. Okay, but remember, you want to factor the original. So the original GCF, we factor out a negative 1. So this is going to become negative 1 times 2p minus 3 times 3p plus 5. Or if you want to, I just want to remind you, see how this is negative 1? Some students, and in most textbooks, they'll write it as negative 2p minus 3 times 3p plus 5. And remember, if you just see a negative, that's understood to be a negative 1. Okay? But again, we always put the monomial factor first. And in another way you could write it is instead of putting 2p minus 3 first, you could put 3p plus 5 first. You could put that factor first. So you could say 3p plus 5, negative 3p plus 5 times 2p minus 3. So there are multiple ways of writing the answer for number 4. Okay? All right, let's go to number 5. Number 5, we have let's say we had this in number 5. We had 27x cubed plus 60x squared plus 32x. So 27x cubed plus 60x squared plus 32x. All right, so if we look at that, the GCF is, okay, so I know that there's an x in all terms, so I know I can factor out an x. That will be the GCF. But in terms of 27, 60, and 32, the largest number that goes into all of those is 1. So the GCF is just x here. So the GCF is x. Okay? So I'm going to factor out the x. So I get x times 27x squared plus 60x plus 32. Okay? So now I'm going to use the AC method on this. Now that's going to be a little bit more difficult because those numbers A and C are not that easy to deal with, the product. So let's go ahead and write it over. 27x squared plus 60x plus 32. All right, and so A is 27, C is 32, and B is 60. So I want to find two numbers whose product is AC, in this case 27 times 32. So 27 times 32 is 864, and whose sum is 60. So this is going to be extremely challenging, right? Okay. So remember the directions. Let me just remind you, if you were told to factor this using any method, then I would probably go ahead and use trial and error at that point. But you got to follow directions. Directions in this case did say use the AC method. So let's continue on with the AC method. So that's why it's important to know both the AC method and trial and error. So that way when you get to a situation, if it did say use any method, then at that point I would use trial and error. But let's continue with the AC method. Okay, so I want to find two numbers whose product is 864 and whose sum is 60. Okay, so two numbers whose product is 864 and whose sum is 60. So that's what I want to find. Okay, so this is going to be challenging, guys. So let's go ahead and do the factor tree for this one, and we're going to have a discussion with what we have. So we want to find the prime factorization for 864. So the prime factorization, and this is going to be for 864. So there are situations where you're going to end up with a problem that's not that easy to deal with in terms of the AC method. So give me two numbers whose product is 864, where one of them is prime. So obviously 2, since that's even. So 2 times, and use your calculator with these. So 2 times 432 is 864. So let's go ahead and break this one down. So that's to even again. So 2 times 216 gives me 432. 2 is prime. So 2 times 108, 2 is prime. 2 times, what's that, 54? 2 is prime. 2 times 27, this is 3 times 9, and then that's 3 times 3. All right, so I've found all the prime numbers. So the prime factorization of this would be 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3, right? Or you can say 2 to the 1, 2, 3, 4, 5, fifth power times 3 to the third power, okay? All right, now here's what's going to happen. So let's think about this. So remember in the previous problems, and the previous problems were easier to deal with. We just looked at two factors and multiplied them together and then wrote it down, right? Now notice though, this is quite a few factors here. There are a lot. And this is a big number, and that's a big number as well. So it may be that your small factors are not going to work. For example, you see I have 2 to the 5th? All right. Well, what about 2 squared? Well, 2 squared is 4, right? Well, 4 will go into 64, but what's the problem? So one of your factors is 4. The other one is going to be 216. Is that going to help you? No, because when you add them up, and by the way, you want the product to be positive, and you want the sum to be positive. That means both of these have to have the same sign. So obviously that's not going to work, right? Because that's going to be 220. You want 60. So maybe instead of using 2 to the second, let's try 2 to the, basically what's happening is this. So instead of doing 2 at a time, you may want to say something like, well, let's use 2 to the third, okay? 2 to the third. Well, 2 to the third is 8. But is that going to help you? So 8 times what's 864? Well, let's see. 864 divided by 8 is 108. That's not going to help either, right? Because when I add them up, I get 116. But then you may say, well, what about if I use 2 to the 4th? Okay, well, let's try 2 to the 4th. You see I'm getting to a point where in our discussion I'm going to say something. But let's just go ahead and continue with this. So 2 to the 4th is 16, right? And so 16 times what's to 864? Well, 864 divided by 16 gives me 54. When I add them up, though, 54 plus 16 is 70. I want 60. Okay, so then it may be, all right, well, what if I use, let's say, 2 to the 4th times, let's say, 3? Well, 1 factor of 3. All right, what's 2 to the 4th times 1 factor of 3? Well, that's 16 times 3. 16 times 3, which is 48. All right, and so that means that 48 will go into 864 evenly. So let's see what 864 divided by 48 is. That's 18. When I add them up, though, what's 48 plus 18? Oh, 66. So that didn't help either, right? So then you go through the process. So then you say, well, so maybe let's try 2 to the 3rd times 3 instead. Okay? 2 to the 3rd, so 2 times 2 times 2 times 3 instead. So that's going to be 8 times 3, which is 24. So 24 times what? 864. Well, 864 divided by 24 will give me 36. And when I add them up, 36 plus 24 gives me 60. I found it right here. So those are my two numbers. That one, notice what we did. So instead of just trying 2 times 2, 3 times 3, you have to use multiples at a time. And that's what we did here. So we tried 2 times 2, which is 4. That didn't work, obviously. We tried 2 to the 3rd, which is 8. 8 times 108 is 864, but that didn't help either. And then we tried, well, instead of just trying 2 powers of 2, let's try powers of 2 with powers of 3 and see if that helps. So we did. We used 1 power of 3. That didn't help. And this one did right here. Okay? So sometimes, I'm just saying, sometimes these numbers are going to be large to where you're going to try many of these before you find the one that works. And that's why I'm saying if you are told you could use any method with these, then at this point, I would have used trial and error. And again, that's why it's important you know trial and error and you know the AC method. Okay, so now let's go ahead and rewrite this. And then we rewrite the middle term using these two terms here, which is what, 24 and 36? So I get 27x squared plus 24x plus 36x plus 32. And so now I'm going to always double check to make sure that does equal this, and it does. So I'm going to group. So in the first group, it looks like I can factor out a 3x, and I get 9x plus 8. In the second group, it looks like I can factor out a positive 8, and so I get 8 times, I'm sorry, not 8, excuse me, I apologize. It looks like I can factor out what, 4? 4? So that'll be 9x plus 8, is that correct? All right, so if I'm doing this correctly though, this is factorable, then these two should be the same. Okay, that should be the same. And these two groups should have the same factor. So they both have 9x plus 8. So I'm going to factor out a 9x plus 8. And I get 3x plus 4. Okay? And so now always double check to make sure you get this back. So always follow this out. So now my final answer, then remember the GCF is x. So you got to factor out the x. So you get x times 9x plus 8 times 3x plus 4. And so notice that this trinomial can be factored as 3 factors, x, 9x plus 8, 3x plus 4. And again, always put the monomial factor first. So I get x times, and it doesn't matter whether you put this first or this first. So you could say this, or you could say 3x plus 4, x times 3x plus 4 times 9x plus 8. And so that will be your answer. Okay? All right, so again, you could, when you're dealing with the AC method and you're told to use the AC method, you will at times have situations where this will be challenging to deal with. It helps if you use a factor tree in that situation. All right, so in a previous courses you dealt with finding the prime factorization of composite numbers. Okay, so that is going to be the end of our lesson on using the AC method, and this was part 2 where the GCF was other than 1. So using the AC method on factoring trinomials. Okay, so that's the end.